Hi, good day all. Today we'll be doing May, June 2021, number 6. Now let's read this question one time. The question says, Farmer Brown makes a truss to feed his farm animals using wood that is 5 centimeters thick, right? As shown in the diagram below, the truss are rectangular base, opens at the top and have an external dimension of 300 centimeters. So this is external, that is inclusive of the 5 centimeters, by 190 centimeters by 160 centimeters. Show by calculation that the internal, so the external is these values. They want to know what is the internal capacity of the truss is 9,091,000 centimeters cubed. So before we start anything, let us find the internal, the length for the internal. So my internal from here to here, right? We'll use red so we can see it, or blue. Let's use blue. Right, from here to here, the entire thing is 300 centimeters. Yes, but we are taking out 5 centimeters from here and 5 centimeters on this side. So that's 300 minus 10 would be 290 centimeters. That is the length. Right, and then let's look at the width. We're going to go from here to here. Let's put it in blue. Right? So we know again that this entire thing is 190, but there's 5 centimeters on this side and 5 centimeters on that side, right? So that would be 190 minus 10, which is 180 centimeters. And then your height, right? Okay, so if we look at the height, there is a piece here that is also 5. So from here to here, no, that's hold on, no, not there. That. So from, let's get the shapes, from inside here to down here is not 160, but it is 160 minus 5, which is 155 centimeters. So those are your dimensions for my internal, the internal of the truss. So we know that this is a rectangle, not a rectangle, this is a cuboid. So volume of a cuboid is length times breadth or width times height. We know that the length is 290. The breadth or width is 180. 180 multiplied by height, which is 155. Let's multiply this using our calculator. So when we did this, right, and use a calculator, you got the answer that they gave you, which was 8,091,000 centimeters cubed. And that is how you would do this question. Right, let's make this blue. I'm just going to put this back to be blue. Right, so 150, right? So that's how you do this question. Then they said calculate the volume of wood needed to make a truss. So we already know that your internal is 8,091,000. We have to find out what is the external and then minus the 2. So your volume for your external truss, so the total volume is equal to length times breadth times height, which is what they gave us, 300 times your breadth, which is 190, sorry, times your height, which is 160. You use the calculator, 300 times 190 times 160 times 160 is equal to, so my total volume of my box, right, That's with the volume of the internal plus the wood is 91,000, no, not 91, 9,120,000 centimeters cubed. Right? So this total volume is the wood plus your internal. Right? We know our internal is what we found above is equal to 8,091,000 centimeters cubed. So my volume of wood needed would be, you have to subtract these two, because the total volume was wood and internal. The internal is this. So the volume of wood is equal to 912 and 1234 minus 8091 and 3 zeros, right? When you subtract that, 8091 and 3 zeros, the volume of wood would be 1,029,000 centimeters cubed, and that is your answer for volume of wood. Okay, so part C says Farmer Brown must paint the internal surface. The internal surface. You see what they said? The internal surface of the true. Given that 1 gallon of paint covers approximately 280,000 centimeters cubed, right? Determine the total amount of paint in liters that is needed to paint the internal surface of the true. First off, we need to find out what is your internal surface, what is the area of your internal surface, right? So we already know that 1 gallon is equal to 280,000 cm squared, because we're talking about painting it, not filling it up, right? So this is 3.79 liters is equal to 280,000. So we need to find out, right? Yes, we need to find out what is the area for your internal surface. Now, if we were to look at the shape, let's go up and look at the shape. If we were to look at it, there is one square, this is one rectangle here, one rectangle here, one rectangle on this side, one rectangle on this side, and the bottom part, right? So we are going to look at the values, or the length, the width, and the height of our internal surface, right? So if we're going to look at this side here, our length is 290 and our height is 155. So for this surface here, and we have 1, 2, 3, 4 of those, 4 of the rectangles that has a length of 290 and a height, actually no, 2 of those. We have this one here, 1, and the next one here, 2. This is the internal, the blue, the one you see. So we have two rectangles that has a length of 290 and a height of 155. So this is length times breadth, which is 290 times, what is the height? 155. And this would be for 1, so 290 times 155 is equal, so this is one rectangle, right? This is equal to 44,950, right? And then we have two rectangles like that. So two of the rectangles would be equal to 44,950 multiplied by 2. We multiply this, you're going to get 8,990. That is for the two rectangles that we pointed out. Right? Then we have a next two. Right? Rectangle. This rectangle here has a length of 180 as the internal 180 and a height of a width of 155. We have one, two, right? Those two. So again, we know that our area of a rectangle is length by breadth. But in this case, our length is 180 and our breadth is 155. A breadth or width, whichever one you want to put. So rectangle, again, is equals to length times breadth, which is 180 times the breadth, which is 155. Right, so if we multiply that, that's 180 multiplied by 155. Right, this is equal to 27900. Right, and that is for two. One of the rectangles. We want two of the rectangles. So two of the rectangles would be this multiplied by 2. So you know that your two rectangles is 55,800. So we have done this space here, this space here, this space here, this space here, and this space here of the internal. However, we have the bottom part, and the bottom part would have a length of 290. So internal is 290 times 180. It's just one that we have to do. So again, we have a next rectangle as the bottom rectangle. The rectangle is length times breadth, which is, we have 180 times 290, right? When we multiply that, 180 times 290, we are going to get, so that bottom part takes 52,200 cm squared of paint. So now we know the total amount of paint you needed for the surface area to paint the surface area, the internal surface area would be, let me just turn this aside so we can have more space. The total surface area is equal to 89,900 plus the two rectangles, which was 55,800, plus the large rectangle at the bottom, which was 52,200. Right, so let's add it up. 52,200 plus 55,800 plus 89,900. When you add this all up, you're going to get 197,900. So you're going to get 197,900 cm cube for paint. Right? Cm cube. Now, if we know this question, if we look at this question below, they said, let's go to the bottom and I'll go back up. They said that 1 gallon of paint, right, 3.79 liters covers 280,000 centimeters cube. We want to know how many liters. So if, we're going to use that if and therefore, if 280,000 is equals to 3.79 liters, then 1 cm cubed is equal to, where is it? 3.79 divided by 280,000. That's 280,000, right? And therefore, we are going to find out for how much the internal we had was 197,900. Right, which is 3.79 divided by 280, the 3 zeros, multiplied by 197,900. Right, which is what we found out to be the total internal surface. So let us find out. This is multiplied by 3.71 over 280,000. Right? So when we multiply this out, you're going to get 2.62 liters of paint is needed to paint that internal surface. And that is the end for May-June 2021.